Hello and welcome back. And we are in module 11, ADF and data ecosystem integration. We will be having a quick intro about Databricks and Synapse. We're not deep diving into um, both of those concepts because we'll be creating a separate playlist for both of them because they are themselves a vast concepts. So ADF is basically an orchestrator, and Databricks is a compute engine for heavy transformation workloads. So, execute a Databricks notebook. ADF provides dedicated activity called Databricks notebook. This allows ADF to start a Databricks cluster, execute a specific notebook, pass parameters, capture return values, and fail or succeed the pipeline based on the notebook status. So how it works: create a link service to a database using service principal access token or AAD. Point to workspace URL cluster token or MSI authentication. Add the Databricks notebook activity inside. Select the notebook path. Select the cluster and configure optional settings like timeout, retry, and logging. ADF then triggers the Databricks notebook to execute the notebook with full Spark compute power. Now let's see this in a quick action. So here we have a notebook activity. You can just find under the database activities. So here the general properties would be same because it's the activity properties for any activity. The general would be same, like how the time, what the timeout, and the active status, and retrying all these policies. So from here the difference will be there. So database link service, first you create a simple database link service, and we also saw this in one of our previous projects. You can check out whenever you want it. I created a event based pipeline where I just created this, and you just provide a simple basic name, the integration runtime, Azure subscription. Now here Databricks workspace, select the cluster, or you can just create a new one. And it also supports the serverless, but it's more expensive, meaning the servers are completely handled by the database. So authentication type, it could be access token, MSI, or user assigned managed identity. The access token, cluster version, node type, and number of Python versions, and number of workers over here. And if you want to parameterize this link service, you can also do that. And now coming to the settings. So when you select the notebook over here, this is where you pass the parameters to the notebook. So just by passing the parameters over here, you will not get the expected results until you define those parameters within the notebook. Now let's see in a quick way, like in the passing of parameters to the notebook, we have, like I said, ADF passes. Let's say we have two parameters, table name and run date. So ADF passes the parameters to the notebook, but we need something inside the notebook to capture those parameters, right? So we have a concept of widgets in Databricks, which we'll be discussing in that Databricks playlist. So what does it do is it helps us to parameterize the notebook. Let's say you have multiple tables, but you have to run the same transformation steps for each table. You just simply create a widget, and it will appear on top of your notebook, and when you pass that particular name over there, the database takes the parameter from there and it transfer that particular table. Now if you have to repeat the same thing, you have to first create that widget within that notebook. You have to make the notebook accept parameters, you have to make it parameterized, and then when you pass the parameters over here, the Databricks notebook will accept those parameters. And similar way, like if you deep dive into database widgets, you have a lot of options, and one of another option is like to capture uh, the node output from the notebook. So in this, you will be using within DB utils, you have notebook and exit, like pipeline complete successfully. This message you can print out. So when you get an actual ADF response, like I said, while monitoring, you can see the input and output. In the output, you'll be something like this: run output. And now you can use this output to set variable activity, if condition, for each, and pipeline branching. This helps orchestration downstream logic. So it will be very helpful for the downstream activities to, take more inputs from the notebook. when to choose data flows and versus Databricks. So Databricks is kind of a similar topic, but like I said, notebooks is where we get a complete freedom if you're more into coding and something like that, programming. So database notebook provides more security. I mean, not security. Security is like both of them on same level. No doubt in that. But the freedom to code and analyze the data, you have more flexibility in the notebook when compared to Dataflows. It's my opinion, because if you're not really into coding, Dataflows would be to go for you. And now, like I said, it's a low code UI based ETL tool. Transformations are simple to medium complexity. Data volumes are moderate. You want a managed Spark cluster without writing code. You need schema diff support in a visual interface. Sorry. Now, choose the data type when you have a terabytes and petabytes of data, and you need advanced transformations. You need custom Spark code. You want data lake features. You need ML streaming integrations. You need cluster level control and optimization. So rule is data flows visual ETL and full Spark engine with code level flexibility. You use Databricks. Oops. Now coming to ADF Synapse. So Synapse is again a separate block in Azure. It has its own functionality. So we just use a portion of Synapse in ADF, not a complete. This is not Synapse itself. Synapse is way more than what we see over here. So we can see like Spark job definition, and only we can see the notebook over here. Now, Synapse includes serverless SQL, dedicated SQL pools, Spark pools. So pipelines, a built-in version of ADF, and external tables, lake databases, SQL script, and ADF activity with Synapse at multiple levels. So Synapse, where you can directly connect your also the Power BI dashboards, and also it has its inbuilt ADF within Synapse. So we'll be discussing more about Synapse in the dedicated playlist. Now, Synapse has its own version of ADF pipelines built into the Synapse workspace. Like I said, they look similar but serve different purpose. So let's see. Let's, so, so enterprise ETL orchestration, Synapse only workloads, and connectors we have 100 plus. So this is kind of less mature, so compared to ADF, so it has limited, and both support self-hosted integration runtimes, ideal for hybrid multi-cloud and enterprise ETL. Only support Synapse focused solutions. Use case end-to-end pipelines, notebook plus SQL orchestrations. Rule of thumb: if your organization uses Synapse as a main compute, you can use Synapse pipelines. If you need broader connector support and SHIR and hybrid pipelines, use ADF. Most enterprises still rely on ADF for orchestration, even if they use Synapse for compute. So now let's deep dive into how ADF works with Synapse SQL, especially external tables, serverless SQL, and dedicated SQL pools. This is very important part of modern data engineering because Synapse allows you to process data directly inside the data lake without using it first. Now let's talk about external table first, where it's a powerful Synapse feature that allow SQL queries to read files directly from ADLS Gen 2 without loading the data into the tables. So think of it as a external table as a SQL wrapper on top of files in the data lake. So typical workflows is something like where the raw file land in ADLS Gen 2, and from it could be from ADF copy activity, event grid, or any other ingestion pipeline. So ADF triggers a Synapse SQL script like create external table with those configuration or those things, and Synapse reads the data directly from Parquet, Data Lake, and CSV. So ADF orchestrate downstream movements into silver or gold zones then. And why these are used is because no need to load the data into tables first, ideal for Medallion architectures, and perfect for quick validations and use for transformations and aggregations. So works great with Parquet and Delta formats. This is especially common in bronze to silver transitions. And is using serverless SQL via ADF. So it's a pay per query SQL engine. So this is no cluster, no provisioning, no cost until you run a query. ADF integrates with serverless SQL mainly using the SQL script activity. So what ADF can trigger in serverless SQL is like the serverless SQL queries and custom scripts and create table as select ctas and or insert select store procedures, anything you can normally run in an SQL editor. So some of the use cases will be for validation, aggregation, transformation, and metallized um, final report tables and data quality checks before loading warehouses. So you can say an example workflow like ADF ingests raw files into ADLS. ADF triggers serverless SQL to read the files, validates the schema, create a SQL view on or external table. Now ADF continues with the next step, such as load into dedicated SQL pool. Then serverless SQL is an like excellent middle layer between ingestion and warehouse. So SQL pool is nothing but like group of SQL computes within the Synapse analytics. Similarly, Spark pools are also the same. And so ADF connects to Synapse dedicated SQL pools to load the data, run sort procedures, perform ETL transformations, handle facts and dimension loads, and trigger TSQL scripts. Now, ADF copy activity is the first fastest way to load data into the SQL pool from Gen to blob storage on-premise SQL Server SFTP or APIs. For larger data roles, ADF uses PolyBase, um, like copy into bulk insert. They are built for high throughput usually. Now, ADF has a store procedure activity that lets you call this SQL store procedure after loading the data. Use this for like fact table upserts, dimension SCD logic, and aggregation, data cleaning, and merging partitions and business logic. So serverless handles scanning files. Dedicated SQL pools handle the transformation and the warehouse logic. Now the transformation, a very common pattern is like extract using ADF, load into staging tables, and transform using SQL script and store procedures. Now coming to the fact and dimensional loads, ADF orchestrates inserting into fact tables, SCD type 1, type 2, dimensional loads, incremental loading logic, and partition switching, or pre and or post load validations. So dedicated SQL pool handles the compute, ADF orchestrates and schedules. Now coming to some optimized patterns are using PolyBase for high speed ingestion. PolyBase loads data in a parallel from ADLS into SQL pool. It is extremely fast for larger tables. So use copy into for flexible ingestion. Copy into is a simpler than Polybase. So it's basically copy into and the table name from a location with file type Parquet, something like that. So it handles schema drift, supports partition folders, and works with CSV Parquet and JSON. Now, use structure formats like Parquet, like I said, pre-stage data in ADLS stored staging zones. And so ADF becomes the orchestrator while we talked about this. And why we should prefer Parquet or Delta format, because Parquet is a columnar compressed and optimized for analytics. Using Parquet, reduce storage, input output, and query calls and loading times. Pre-stage data in ADLS, like best practice for raw ADLS, like clean ADLS silver, curated for ADLS pool gold, and ADF orchestrate um, each zone movement. And that's pretty much it. And we'll be talking more in detail and in practical way about Synapse and Databricks in a later video. In this way, I just want to show what role does data ADF plays in both Databricks and Synapse workloads. So that's it for this video. See you in the next one. Thank you for watching.